Welcome, everyone, to the explainer that is absolutely, fundamentally going to change the way you approach your math exams from this day forward. We are looking at a brilliantly effective, incredibly critical strategy today, which we like to call the fashion designer approach to perfectly tailored answers. Now think about this for a second. If you are studying for Cambridge AS and A-level mathematics, specifically syllabus code 9709, or even if you're currently laying the essential groundwork with IGCSEs and O-levels using codes like 0580, 0606, 4024, 4037, and 4040, you probably know the exact feeling I'm about to describe. You know the sheer, heartbreaking frustration of walking out of an exam room feeling totally confident, right? You felt like you crushed it, only to get your paper back a few weeks later and realize you literally bled easy marks all over the page. It's maddening. You knew the core formulas, you understood the calculus principles, but on those heavy multi-stage integration problems, specifically finding the area under a curve, the area between a curve and a straight line, or the tricky area between two curves, your marks just seem to inexplicably slip away. So why does this happen? Why do good students lose these marks? Well, because you didn't tailor your answer to fit the exact parameters of the question perfectly. You left loose threads hanging everywhere. And examiners, they don't give you the benefit of the doubt when there are loose threads. Today, we are going to fix that completely. We are going to transform your approach. Okay, let's dive into this and ensure you capture every single method mark available to you in your next paper.
Here is our roadmap for today's session. We are going to systematically build your understanding through 5 distinct steps. First, we'll outline the challenge. Second, we'll do the strategy reveal. Third, we'll look at the transformation. Fourth, we're jumping into an interactive workshop. And finally, number 5, we'll give you the final system. Let's start right at the beginning with section 1, the challenge, and really dig into why losing easy marks in integration is such an epidemic. So why exactly do students lose easy marks on multi-stage integration? Let's really unpack this. In multi-stage analysis questions, like for instance finding the bounded region between a quadratic curve and a linear line, you are dealing with a massive cognitive load. This isn't just a simple one-step operation, where you plug a number into a formula and you're done. No, you have to find the exact points of intersection. You have to correctly set up your integration limits. You have to visually or algebraically decide which function is sitting on top of the other. Then you have to manually execute the integration correctly, and finally substitute those limit values without making a single arithmetic error. It's a lot. To understand where this goes wrong, let's look at a typical exam scenario and contrast 2 very common student personas. First up, we have Alex. Now, Alex is incredibly smart. Alex knows all the integration rules by heart, knows the calculus inside and out, and basically overloads the exam answer space with raw, unfiltered mathematical facts. But here is the problem. Alex provides absolutely zero analysis. There are no clear upper and lower bounds stated, no intersection coordinates explicitly calculated and clearly labeled, just a massive chaotic jumble of algebra all over the page. The examiner literally cannot follow the logic. Then, on the other end of the spectrum, we have Sam. Sam completely understands the underlying concept, but is constantly rushing against the clock. Sam is just so eager to get to that final decimal answer at the bottom of the page that they completely miss the crucial command words in the prompt. If the question explicitly says, show that the exact area is, and Sam punches it into a calculator and provides a rounded decimal approximation, Sam loses the marks. It's that simple. Both Alex and Sam are leaving their papers covered in red pen, not because they don't know the underlying math, but because their procedural framework, their approach to communicating with the examiner, is totally broken.
And this dynamic brilliantly illustrates the core difference between the deeply flawed final answer only approach and the highly examiner-preferred structured working approach. Let's break these down. The final answer only approach is rushed. It's incredibly superficial. It assumes the examiner just wants to see the magic number at the end of the page and nothing else. But you have to remember, the academic benchmarks for Cambridge integration questions require logical, highly structured reasoning. The entire assessment framework prioritizes analytical depth over superficial breadth. The examiner doesn't just want the answer. They need to see your actual mathematical brain working right there on the page. In contrast, with the structured working approach, you are actively demonstrating connected understanding. You are explicitly proving to the examiner that you know exactly why you are subtracting the lines equation from the curves equation before integrating. You are showing systematic, step-by-step analysis and evidence-based reasoning. Remember this, top-performing candidates always exhibit a conceptual understanding that is fully transferable to unfamiliar contexts, and they prove that understanding through their clear, step-by-step written logic. They don't leave anything to guesswork.
Moving on to section 2, the strategy reveal. Here is where we outline the theoretical and procedural blueprint. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations.
Click that subscribe button and hit the bell icon right now. Okay, it is time to uncover the exact workflow that takes a messy, chaotic integration attempt and turns it into an undeniable, bulletproof mathematical proof. Let's really break down the foundational problem-solving workflow that is expected by Cambridge examiners. Step 1 is to deconstruct the given information. When you look at a graph showing an area bounded by a curve and a line, don't just stare at it. Extract the data systematically. What are the specific equations given? What are the visible intersections on the axes? Identify every single one of your key elements before you write a single piece of calculus. Step 2 is to solve systematically. This means breaking the entire problem into logical, bite-sized steps. First, explicitly equate the two functions to find the x-coordinates of the intersections. Show that algebra clearly so the examiner sees your method. Then, set up your definite integral, explicitly writing the upper and lower bounds on the integral sign. Execute the integration with crystal clear working. Step 3, and this is the one everyone skips, evaluate for reasonableness. Actually look at the visual representation on the exam paper. If the shaded area on the graph is just a tiny sliver between two intersecting lines, and your calculated area at the bottom of the page is 450 square units, well, something went horribly wrong, right? You need to verify your results against the context of the question before you confidently move on to the next page. To make this even easier, we can actually adapt a classic essay writing tool for complex calculus. I'm talking about the Peel framework. Now, normally you hear about Peel in subjects like English literature or history, but let me tell you, it is an absolute game changer for multi-stage integration in math. Let's map it out together. P stands for point. Identify the core element of what you're doing. For example, write down explicitly on your paper. To find the integration limits, find the intersection of the curve y equals x squared and the line y equals 4. You are telling the examiner your exact intention. E stands for evidence. Apply the mathematical principle. Actually write down the equated statement, x squared equals 4. E is for explanation. Execute the analytical working, show the intermediate algebraic steps. Write x equals 2 and x equals -2. Then, deliberately set up the actual integral expression, showing the upper line's equation minus the lower curve's equation. Finally, L stands for link. Verify and present the result. Evaluate that integral, carefully substitute your upper and lower bounds, and clearly link your final numerical answer back to the original prompt, boldly stating area equals 10.67 units squared. By intentionally tying your point to evidence, explanation, and a link, you perfectly structure your working. You are literally making it impossible for the examiner to deny you your method marks. Let's transition into Section 3, the transformation, where we decode the actual examiner warnings. But stop scrolling. Subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back into it. It's time to decode the actual, literal warnings left behind by Cambridge principal examiners in their annual reports. Understanding exactly what goes wrong in the exam room from their perspective is the secret to turning red pen marks into green check marks. There are exactly 3 critical warnings pulled straight from these reports that we absolutely need to address today. Examiners read thousands of scripts every single exam series, and let me tell you, they see the exact same patterns of failure repeated year after year. These aren't just polite, minor suggestions. These are massive, grade-destroying roadblocks sitting right between you and top marks in your calculus modules. So the absolutely crucial point here is understanding these top 3 recurring mistakes so you don't make them yourself. Warning number 1, straight from the examiner. Answers are often too vague. Examiners want specific mathematical details. In the context of integration, this means failing to write down the exact integrated expression in brackets before you start substituting your limits. If you just jump wildly from the initial integral symbol straight to a calculated final number, that is considered way too vague. You get no method marks for what happens in your head. Warning number 2, students constantly forget to check format and presentation. Basically, this means sloppy algebra, forgetting to write the dx at the end of your integral setup, dropping negative signs when subtracting the lower limit evaluation from the upper limit evaluation, which happens all the time. Poor presentation destroys your method mark potential because the examiner literally cannot follow the chaotic logic of your steps. Warning number 3, answers lack specific context. Think about this. If the question asks for the area between 2 specific curves, and you accidentally integrate the wrong function, or you don't realize that a portion of the area actually dips below the x-axis and technically needs to be split into 2 completely separate integrals, you have completely ignored the physical context of the mathematical landscape provided. You have to pay attention to the graph. I really need you to let this next quote burn into your memory. This is a direct alert. Examiner alert. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. process matters just as much, if not more, than the final answer. Let's say you do an incredibly complex page of calculus, but you mess up 2 minus 5 on the very last line of the page. If your integration technique was completely perfect and your upper and lower bounds were totally correct, a 6-mark question might still easily yield you 4 or even 5 marks. But if you show 0 working, just type it into your calculator and get that final number wrong, you get an absolute 0. The choice is yours. Let's move into section 4, the interactive workshop. It's time to test your skills and spot the flaw. Okay, you've heard all the theory, now it's time to put your own analytical skills to the test. Let's step directly into the shoes of an examiner for a minute. Take a look at the 2 columns of working. I want you to compare the flawed integration working on the left with the absolutely perfect structured working on the right. Notice exactly what is missing on the left side. The student has casually written down the integral sign, they put down the basic functions, but there are absolutely no upper and lower bounds specified. None. They just randomly integrate and magically produce a number out of thin air. How did they get the specific area without defining the boundaries of the region? This is a textbook, classic example of vague, unsupported work that examiners hate. Now observe the perfect structured working on the right. The student explicitly states limits are x equals 1 to x equals 4. They carefully place the 4 at the top of the integral sign and the 1 at the bottom. They show the actual integration step neatly enclosed in square brackets with the limits positioned on the right side. Then they explicitly show the substitution step, the upper limit evaluation entirely in one bracket minus the lower limit evaluation entirely in another bracket. This perfectly structured approach correctly extracts the core mathematical trend, uses undeniable evidence-based reasoning, and frankly guarantees every single available method mark. So I have to ask you, which approach are you currently using on your practice papers? To help you rapidly evaluate your own performance mid-exam while the clock is ticking, I want to give you this incredibly quick memory hack derived directly from those examiner warnings. Just remember VFC. When you finish a massive, intimidating 7 or 8 mark integration question, force yourself to take just 3 seconds and ask yourself these 3 things. 1. Is my working vague? Did I skip crucial algebraic steps that I just lazily did in my head? 2. How is my format? Are my brackets aligned properly? Did I remember the dx? Is my handwriting actually easy for a stranger to read? And finally, 3. Context. Does my final numerical answer actually make sense in the context of the visual graph provided? If it's a massive, clearly huge area taking up half the page, and my calculated answer is 0.5, I need to go back and check my context immediately. Use the VFC check before you ever turn the page. Finally, we have reached section 5, the final system. Let's lock in the method mark strategy. We are bringing together absolutely everything we've discussed today into one unified, complete mathematics answering system. If you want top marks, you must follow these 3 absolute rules. Rule number 1, command word decoding. You have to know the specific difference between calculate, show that, find the exact value, and determine. Each of these words requires a totally different level of explicit written working. If it says show that, it means the examiner literally already gave you the answer. The marks are 100% for the journey, so do not dare skip a single algebraic step. Rule number 2, peel framework application. Make your point clearly, show your evidence through established mathematical principles, execute your explanation with flawlessly clear working, and link it to a final verified result. Rule number 3, the time management matrix. Complex multi-stage integration questions are almost always heavily weighted, often pulling in 6 to 9 marks. You must dedicate the proportional time to them. Don't rush through calculating your limits and bounds, because if your bounds are wrong right at the start, the rest of your beautiful integration on the page is practically worthless. Apply these 3 rules systematically, every single time. So the final ultimate question is this: are you ready to secure every single method mark and truly transform your exam results? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.